Well, good evening, everyone. Thanks so much for joining me tonight for another Tech Talk with Judith. And tonight we've got Katherine Williams, who's joining us from BDL 3D. Thanks for being here tonight with us, Katherine.
Thank you very much for taking the time to chat to me this evening.
Because this is quite interesting. I mean, we've got BDL is a 3D printing service with a goal to revolutionise not just printing, but actually manufacturing. And it's by helping customers convert from traditional production methods to digital manufacturing. And it was incorporated in Christchurch in 1973, selling and servicing photocopiers for almost 50 years. And it remains under family ownership, and that's the Huston family of Christchurch. But BDL 3D was incorporated in November 2022 to grow the 3D printing service side of the business. And I've been to see the business, and I've met Katherine before. And so let's have a talk about some of your background of yourself and BDL and the inception of BDL 3D, because this is an enormous step that BDL has taken.
Yes, it is. Yes. So myself, I'm the business development manager for BDL 3D. I've worked at BDL for around about 7 years now, so I've been involved in the print side of things. A few years ago, the company directors took a trip to Barcelona. They were lucky enough to visit the HP Centre of Excellence, which is where they saw this 3D HP multi-jet fusion 3D technology. They were quite excited by it, fell in love with it, and thought, the possibilities in New Zealand for this technology would be great. So, like you said, it is a big step for BDL. Because it's been a significant investment, to try the technology out and revolutionise the way people are doing things in New Zealand. So in February 2022, we received our first 3D printer, which was the Colour HP 580 multi-jet fusion. That was great for allowing us to sort of test the waters in New Zealand. That soon became running to capacity. So February this year, we've just received the large-scale production printer as well. So that's capable of doing sort of high production, big capacity runs for our customers.
So what is 3D printing, Katherine?
So 3D printing comes in many forms. There's obviously sort of FDM 3D printing, which a lot of people are familiar with. It's sort of extrusion 3D printers. Lots of schools, people have them in their offices, those sorts of things. There's also SLA, which is a common resin liquid type 3D printing. Or there are things like multi-jet fusion, which is what we have, and SLS, which are both powder-based 3D printing technologies. So the HP multi-jet fusion is what we use.
So let's just get this clear for everyone watching. We're not talking about printing our colour photographs here.
No, we're not. We're talking about printing, fully functional models, working parts, all those sorts of things.
Now, how does it work, Katherine?
So all types of 3D printing are made up of a process of basically turning a 3D model into a solid object by building layer upon layer. So you've got either a CAD design or a scan of an item, which then gives us a file which we send to the printer. So multi-jet fusion, our type of 3D printing, uses a nylon PA12 powder. It builds those powder layers up in very fine 80 micron layers, which then the printer lays a detailing and fusing agent over those, and it's bonded then using heat. And the end result is, very strong, highly accurate 3D printed parts, actual functional sort of.
Let's have a look at some of these examples you've got, Katherine. So what is that you've got?
So this example here is just showing this is what would come off our production printer. So this is the raw grey material. We also have things that are with the colour printer that I previously mentioned. We can print things in full colour.
Now I tried this when I was visiting you, and it's very compulsive, actually.
It is. Everybody seems to like this, and we have all sorts of toys that end up on our desk for people end up fiddling with. But we're not just obviously manufacturing toys. We're actually making real functional parts for many different
What I
industries.
found fascinating with that is that clearly there's the strength part of it, which is, obviously but there's also the flexibility, and all of that
Yes.
is this 3D printed, um,
Yeah.
process.
Yeah.
It's
So I
just,
mean, the flex and so on is all about the design of the product. So you can create something that's solid and hard. These areas don't bend. Whereas we've got this sort of spring type function here, or this is flex, but we've also got very solid, strong parts as well. So it's all about the design techniques that are used.
So, any other particular examples you can show us?
Yes, we've got lots. We are doing a lot of work for the artificial limb service. So here is a prosthetic limb, which is worn by a patient day in, day out. We are printing things such as AFOs. Some people may have seen these before.
So what is that, Katherine? Because that
so this is, for example, when a child or somebody has maybe cerebral palsy, for example, and they need an ankle foot orthosis. So these are braces or supports that they would use. They sort of wear that, they'd have strapping and so on around it, and that would be something they're wearing day in, day out. So the ability to be able to personalize these things, somebody here has chosen some skulls. We see all sorts of designs, but
so this is like a modern day cradle, essentially, to hold the limb and to give support for the person who has, say, cerebral palsy, to be able to walk in a much better and more supported way.
Yes, that's correct.
Fascinating, isn't it?
It is. It is great to be involved with.
You must be really excited about this, Katherine, because this is changing people's lives.
It is changing people's lives. It is. We're covering so many different industries. So we, other companies that perhaps sort of engineers, all sorts of people like that are revolutionizing the way that they're doing things. They're able to change things. They've done something a certain way for the last 20 years, and now they can, redesign and have a lot more freedom in what they can actually produce. So, yeah,
so
it's exciting.
When you're doing work for the Artificial Limbs Board, you're actually making a prosthetic for someone to perfectly fit them.
Yeah, so we're not involved in the creating of the design as such, because of course that's left to the professionals who are dealing with knowing exactly what the sort of medical intervention is that is required. So they'll send us their files that are ready to print, but basically they're doing those from a scan of the patient. So each device that we print is personalized to that patient. It's custom designed for them. So it will only fit their limb, not, it's not a sort of bulk production thing.
And that that one you showed us before, the prosthetic, that looked, that was really shiny and everything. So what's involved there? What are you using?
So this one's actually just been painted by an auto body company. So this is one of the surface options you can get. We can dye things as well. So we're doing all sorts of different finishing techniques.
That's your tape measure, isn't it? So
it is. I was keeping that one for later, Judith.
It's just fascinating. So are there, which are the particular key industries that you're seeing utilizing this technology?
So, the beauty of MJF is that it fits into so many different industries. We, in New Zealand in particular, at the moment, we've been doing a lot of work in the medical space, as we've already discussed. We've done a lot of things for aerospace companies, product designers, marine, automotive. They're probably our most popular. The medical industry is a key industry because it's taken off worldwide already. So people are, they can gather that research from overseas, and they're quite comfortable in implementing it in New Zealand. And they're doing the custom orthotics and prosthetics, surgical guides, all sorts of things like that. So, there's no industry that it doesn't cover so far. We've not found any that there's not a use for it. So, it's really exciting talking to new customers and them understanding where they can fit this process into their current business workflow.
So, how is 3D printing different from those traditional production methods, and how could it be used?
So, I mean, it's different because, as you've already seen, you can create truly custom parts. So it's not something just off the shelf. It also helps companies to mitigate those sort of expensive setup costs for parts where they might have traditionally had something injection molded, but the mold setups cost, in the thousands, and they would have to utilize that for a lot of parts. Whereas, they can do one design and then they can send another iteration the following day and make slight changes and modifications until they come up with the part they actually want. They are not having to hold a minimum order amount of quantities. They've not got all that sort of warehousing because they can order as and when they need something. And also the fact that they can get a lot of parts now here in New Zealand that normally they would have to get from overseas. Other traditional sort of manufacturing methods such as CNC sort of starts off with, if you think you've got a block of material, and to create the end part, you're taking away the excess material to create your part. Whereas what we're doing is actually you're only using the material that you need to create that part. So you're building on, not taking away. So obviously reducing waste as well.
So very little waste compared to normal production
Yes.
method.
Yeah.
And so what are the benefits you're seeing to businesses who are adopting digital manufacturing, such as 3D printing? Must be some good examples.
I mean, obviously they've got sort of faster turnaround because, things are made right here. So generally somebody will send us their print ready file and they'll have their parts dispatched usually within sort of 2 to 3 days, or, maximum of week turnaround. Reduce costs because let's go back to the prosthetics, for example. They would have a technician working in the workshop creating those prosthetic limbs from casting and all those sorts of. So there's a lot of time involved in that, whereas all they're doing now is scanning their patient, designing the file, and then sending it off to be produced. I guess other benefits are the ability to change designs. They can change the way things have been done for so many years, and it gives businesses the opportunity to rethink and be a little bit more innovative.
So that's interesting, which is this innovation is leading to businesses and others being able to innovate even more to what they were doing, because they can think of things that some of those constraints that they've had traditionally have gone or are no longer required. It's very interesting. So, how would you place New Zealand in terms of knowledge, adoption, and capability when it comes to 3D printing?
So, with regards to multi-jet fusion, for example, New Zealand, I hate to say it, but New Zealand is far, far behind the rest of the world in the adoption of this technology, which I guess is quite a benefit to what we're actually doing, because we're able to take that all of that hard work that's already been done overseas. They already know what industries this is applicable to, and so we're able to adopt that and bring that within New Zealand. It is a relatively new technology in New Zealand, which therefore, I mean, we've got a variety of customers. We've got customers who already knew about the technology and were using it overseas, so obviously they're thrilled to now have this here in New Zealand. We've also got a lot of customers who are not familiar with multi-jet fusion technology at all. Customers like that, like I mentioned before, it is great to be able to go into their business and show them where it fits into their workflow. There's a little bit of education required around design of products and so on, because when people think 3D printing, there's all about support structures and all those sorts of things. Whereas with the tape measure, Judith, that we've already touched upon, with multi-jet fusion, you can print a part all in one piece. So this tape measure here is a functional tape measure, and this was printed in one piece on the printer. We obviously then sort of unpack that out of the powder bed and blow off all the excess powder, and there you are with your fully functioning moving part. So
I was fascinated by that when I saw it.
It is really good.
You made it in one go. I mean, that's just extraordinary.
Yeah, nothing was pieced together afterwards. It's all the lever and everything all as one functional piece. But with this is just an example of showing people how they can rethink their designs, and it allows a lot more freedom for making things that haven't been able to be made before or in new ways.
So in terms of the strength of the product that is then made,
Yeah.
how would that differ from more traditional methods?
It depends on what application you're using it in. There are a lot of companies that would have traditionally used a metal part, for example, because they see that as being the part that they need, whereas actually, the strength, it depends on the design of the piece, but it is able to be swapping out metal in certain parts, and its strength to weight ratio is far beyond many other manufacturing techniques. So that's great that people can sort of reduce the weight of an item. It's quite popular in end of arm tooling for robotics because it's light, but it's also strong enough to actually be functional. So,
And because you're based in Christchurch, you've got an aerospace industry now in Christchurch.
yes.
There must be huge opportunities there for you without telling any secrets. Clearly,
Yes,
that would
there
be
are. We have spoken with a few of them, and we have done prints for a few of them. There are a few in other areas of New Zealand too. But yeah, there is an industry in Christchurch which is very exciting to be involved with, and also they're very excited about having access to multi-jet fusion too. So.
And I was fascinated by the speed at which these new parts, for instance, are created. I mean,
Yeah.
that tape measure, how long would that take to go through and be created?
Well, I guess the difference with multi-jet fusion printing compared to your sort of more commonplace 3D printing techniques is it's not an end-to-end process. So we can have a build chamber full of, a large amount, maybe 50, 60, 70 of these all stacked up. So you're not producing one part end to end. There is, because of the heat involved in the manufacturing process, there is quite a sort of large cooling time. So once a build is finished, we put that aside to cool. But the beauty of our large scale production printer is that when that one's cooling, we've already got the next build on, creating the next batch of production parts for our customers. So like I mentioned previously, the turnaround time is usually around about 2 to 3 days. It's all about when we're running our builds and what parts we can fit in those builds. So it really is very much like a game of Tetris for my colleague who packs the builds. We get all of the files from our customers, and he has to pack those in the build chamber in the most efficient manner to try and keep the turnaround quick for our customers.
In fact, the build chamber, the way it was stacked, when I had a look at it on your colleague's computer screen, it looked a lot like a pottery kiln with lots of different things in it, except that
Thought of it that way.
was different that it was going to be. So it's quite extraordinary, and it's not. It comes out like that. I mean, that's the computer program that's going in there. It comes out with all these different things that have been built. So how can people reach out if they're interested in knowing more about the BDL 3D printing services?
So, I would love to chat to anybody that even just wants to, even if they're not ready to print something, but they just want to learn a bit more about the technology. Easiest way is probably to look us up on the website, which is bdl3d.co.nz. And there's a contact us form there if they wanted to just send a message through to me, and obviously I'll contact them back. Alternatively, in Christchurch, we love to have people come in and look at the printers, look at some of our samples, just to touch and feel multi-jet fusion parts and see how they stack up to their expectations. So people are more than welcome to just contact us via the website, and I'll be in contact. They can come and have a look around and see the machines and so on. It's actually very useful when people do pop in, because it does help them to understand the technology a little bit more, because once you see the machines and you see how things are produced, it's quite beneficial.
It's fascinating to see, and of course what you produce is very tactile too, so people want to touch it. But you still do traditional printing as well, in the normal?
Yes, we do. Yes, so that is BDL. Obviously, we've got BDL, then we have BDL 3D. BDL 3D being the sister company. We kind of do our own thing, and then we've got our excellent team with all of those 50 years of experience dealing with office print and so on. So, of course, people can always contact us for that too.
Right. Well, thank you, Katherine, very much for your time tonight, and thanks for showing us some of those examples. But it's fascinating work,
It is.
and it must be so. Let's say, in many ways, for the team, wonderful to be able to help people who need prosthetics as well. I mean, just a
It is.
wonderful thing to be able to do.
It's one of my favorite parts of the job. So yeah, it is. It's very good.
Really making a difference for people's lives. Thanks very much, Katherine, and good evening.
Thank you very much, Judith.